So we are going to go over this classwork problem in case you didn't quite understand how to do it. We are going to use similar triangles to solve this word problem. And the reason that I know we're going to use similar triangles is based on the picture. We have like a lamppost, we have a man. The man is standing a certain feet away from the lamppost, and then because the light is here, that creates like a shadow. So we have a shadow, I'll call that S, and I'll call like his length away, that's X. And so as you recall from geometry, you have like a larger triangle, and that ratio will hold true because of the angle measurements by angle, because these are both right triangles. And then this angle within the large triangle is the same as this angle in the small triangle. Sorry that my picture is terrible. And we are told that the lamp height is 10, the man's height is 6, and then again, this is the shadow, and then this length here would be X plus S. So it's not his distance away, it's his distance away X plus his shadow length. So just make sure you have X plus S, both of those. So when you have that X is equal to 20, because he's 20 feet away, you can plug in 20 for X. And then what you're doing is you're setting up a ratio here. And there's a couple of different ways to do it. You can say, okay, 10 is to 6. So you're comparing like the large triangle to the small triangle. So 10 is to 6 as X plus S is to S. Again, that's an S, not a 5. That stands for shadow. So you could set up the ratio this way, or you could set it up as, well, the height of the large triangle over the length of the large triangle is equal to the height of the smaller triangle over the length of the smaller triangle. So you can set it up that way. You'll notice that it is exactly the same, because when you cross multiply to solve, you're multiplying the same things. So either way, I get S times his shadow length is equal to 6X plus 6S. Now, it says that he walks at 4 feet per second away from the light. Now, that would give me some information if I was actually calculating any rates here, but I am not calculating any rates for this problem. So it's actually extraneous. I actually don't need it because that's a rate. And just because he's walking 4 feet per second away from the light, that doesn't actually change his distance away, because I'm already given his distance. It's either t or it's in part A, it was 20. So that part is confusing to students, because where do I use that information? Well, I mean, if he's 20 feet away, it tells me that that's 5 seconds after he started walking away. If he started at the light, that would be 5 seconds. But I'm not using any time element in order to solve this problem. I'm using lengths only. So I don't need the 4 feet per second. That doesn't tell me anything. When I get to calculus, I will need to use that rate. It's something called related rates, but you don't need to know that yet. So right now we're just kind of learning to set things up, because this is pre-calculus. So anyway, when he is t feet away, so that's actually my X here. So 10 times S is equal to 6t plus 6s. And then what is the length of his shadow? So I'm going to go ahead and solve for shadow. So I'm going to subtract 6s. I get 4s is equal to 6t. And then s is equal to 6 over 4t. So the length of his shadow is 3/2 t, where t is feet. So this is also confusing, because t is generally time, but it's not always. So in this case, they're saying t feet away. So if he was 20 feet away, for example, then that would give me 3 times 10, so that would be 30 would be the length of his shadow if he's 20 feet away, et cetera, et cetera. But this here is the expression for any t feet away. So that's it. So if you ever see problems where you have kind of a triangle within a triangle, it doesn't necessarily mean you're going to use similar right triangles, but that is a common geometric strategy that we use.